message to the co. Yeah, now you can message to the co-host, please. Yeah, hello Kishan, good evening. We'll wait for another 4 minutes. If we'll see if students join. Otherwise, we'll start the class at 8:50. Till then, anyone having any doubts or questions, they can ask me. And Kishan, I've seen you have sent the code. Yeah, but I have not gone through it as of now. We'll look into it. Was it working fine? No. Did you have you guys did the questions on some kind of coding platforms like HackerRank or LeetCode or something, or you are just trying it on your local ID? Okay, so this unique problem, did you got anywhere? This unique numbers problem, did you found anywhere? Did you find anywhere? Didn't search for unique numbers. Okay, but it is there on interview bit probably, so you can look into that, or you can also look for it in the lead code. Both of the places it will be there. Yeah, but there is like normal in the normal hacker rank also. If you will search, there are few very easy like linked list questions. So yeah, you can do that. Are you guys able to see my Eclipse screen? Okay.
I'm not able to see the
Yeah,
screen.
it's fine. It's fine. Actually, I was just checking it because it was showing me that your Eclipse screen is being shared. I'm just trying to test your code, nothing else. Okay, we'll start the class now. Yes, so unique numbers, anyone of you are stuck in? Oh, sorry, I already told the code, right? Or did I not? Yes, did I explain the code for unique numbers in the class? I gave you one hint, that's for sure, but I guess the code I didn't explain. Anyone wants me to explain the code? Okay, I'll explain that. Hope you guys practiced on the linked list these days. And the coming 2 days as well, you're gonna practice. Okay, then. So as usual, if we are doing this unique element thing, we first thing that we need to check is if the coming head is not equals to null. That means if head is equal null, in that case, you simply need to return your head, right? The next thing I told you all that you need to have some dummy node, like as Vishnu that day pointed out that we will have some node to which we will attach our unique nodes, right? So for that, I'm naming that node as a dummy node. Let's call it as a D only. I'll give it some random value, 0. Any value you give it, it doesn't matter. I am just assigning it with a very basic value. Next, you know that at the end, like let's suppose this is your first node 0, you connected it with another node, some other unique node 1. When you have to connect it to some other node 2, then your dummy node should be here. Then only you can write d dot next equals to 2. Yes or no? Like every time you need to move your dummy node. So at the end, when you need to return your unique nodes, you won't be having a starting point. Yes or no? Yes. And for that reason, you should be storing it in some temporary variable. Let's call it as a temp, and you store your D in it. Clear? And everyone understood this as of now?
No, madam, I couldn't understand. So I'm understanding that zero, you just want to keep it. If there is nothing returned, then at least D will be returned with a zero
No,
thing.
no, 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 no. It's not like that. It's simply like that 0, like I should have some starting point from where I can start connecting the nodes with, right?
Yeah,
Otherwise, how will you start connecting the nodes? Like you can't randomly start that, okay, I have got a unique value. From here is my starting point, right? So I'm
yeah,
giving you a starting point that is D. So whenever you get some unique node, you will just attach to it like this, you attach a unique node. At the end, when you have to return your answer, you won't be returning temp directly.
correct.
you will be returning temp dot next,
Next.
because from here onwards your unique list starts. Clear?
Yeah.
Yeah. But now the next thing which I explained is that whenever you will be connecting the nodes with D, like let's suppose this was your initial point 0, you connected some unique node 3. After that, if you need to connect 6 to it, let's suppose another unique node, then your D should be here. Like initially your D was here, then you transferred it to here so that the other remaining nodes can be connected. You remember, na? Like once we attach a node, then we keep on jumping on it. Like every time it's like D dot next equals to the incoming node. Are you getting this? Okay. So you understand why I have taken temp and D? Any doubt, any questions so far? Okay. Now, the next thing which I told is that you should be having some Boolean flag. Okay. Boolean flag indicates that as of now you have, sorry, Boolean flag indicates that as of now we are assuming the current number is unique. But as soon as we find that there is some duplicate data for that, we make it false. Clear? So initially, I'll just take Boolean and the name will be unique, which will be as of now true, assuming that the number is going to be unique. And as soon as we find its duplicate, we will make it as false. Now comes the chance of our head. So we will run our linked list until we have not reached the end. But as of now, I'm not specifying any condition because we don't know what to specify in here. The first thing I told you, if your linked list look like this, 1, 1, 3, 7, 7, 8, 9, and 9, then what you need to do, you just need to pick this number as some central point and then need to compare it with other numbers, whether the other numbers are equal to this current number, right? So for that, you need to take some some variable here int x equals to h dot data. Now, right now your unique is true, but here also you ensure that your unique was true because it's a while loop, right? So inside that, make it as a true. Or better, you can just declare it above the while loop and you can initialize it inside the while loop. Next is you need to check inside it in a very similar way, the way you were checking for the duplicate elements. That is, while h dot next is not equals to null and h dot next dot data is equal x. If both of these conditions are true, then in that case you need to yeah, obviously we need to make unique as false. That's one thing. Other thing, unique is false. Delete the occurrences. That means you will move your next. That means you will write here h dot next is now equals to h dot next dot next, right? Okay, great. So until you are getting the similar values as x, you will be continuing in this while loop. Clear or not? Yes. Once this one is covered, now you have got 3. Okay. The other time when it will go and check if h dot next dot data is equal x, will it be equal? No. Now, since it is not equal, what should I do further? Now I need to check it for 3, and nothing should be attached to my dummy node, right? These are the two things I need to do, that nothing should be attached to my dummy node. And the other thing is I need to start traversing for my current new number. So can anyone help me with this? That is okay if unique is equal to that, we will do. How?
Assign h equal to h dot next.
H equals to h dot next.
So
Okay.
that head becomes the next element becomes the head.
Okay. So you are saying I should make h equals to h dot next. Good. So now in my current h dot next, it was 3. So 3 is getting stored, right? The next thing is you need to check if the previous number was unique or not. So you will check here if unique. Then you need to attach it to the dummy node, that is d dot next is equals to d dot next is equals to h. But now you have changed your h, right? Now what will you do? We can do it like the other way as well. That is, I can assign it later, but then also it will be a problem. I'll, I'll show you how. D dot next equals to h, and then you need to ensure that whatever number you have connected, its next node should be null. But right now, your h is connected to so many nodes to it, right? Like so many nodes after that. So we also need to make sure that your h dot next is equals to null. So when you do this, you are gonna lose your link to 3, right? Are you guys getting it? Kishan, you assigned your d dot next to h. Okay. When you assign d dot next to h, that's fine. The other thing you need to do, you need to make this h dot next equals to null. Otherwise, there are lots of nodes which are attached to h right now. Getting it? Right. So when you do these 2 steps, you are losing your link to 3 because you are changing your h dot next to null. And that somehow we need to preserve. How you are going to do that? Yeah, right. So you need to create here. Better you don't create the node inside the while loop, because every time the node will be created, you just take the node outside this and take it as some, what, I'll take it as a k as of now, not temp, and just do here, store your next k is equals to h dot next. Clear, everyone? After this, when you are done with your like this h dot next equals to null and dummy dot next, you need to move your dummy equals to dummy dot next. And that's it. After this, you need to assign again your h equals to your k. Yeah, right. Not h dot next. Yeah, right. And then you can close your while loop. At the end, you can return your td dot next. Sorry, temp dot next, not td. Temp dot next. Clear? What will be the while condition? Anyone who can tell me what will be the while condition? H dot next not equals to null. Are you finding any point where if I'll write H not equals to null will fail? Yeah, right. It should be. At the end, we are using where? Yeah, right. So here it should be H not equals to null. Anyone who is having the confusion in this, you can ask your doubt to me.
Ma'am, why are we taking K?
Why are we taking K? Okay. So Vishnu, as you said that like we want the new head, so new head with H is equals to H dot next, right? You said that.
Okay, new head for what? D to
No,
store.
after coming out of this loop, while loop, the inner while loop, I
Mhm.
told you that now we have to look in the same way for 3, right?
Yeah,
So when I told you, okay, how we will look for 3, so you said our new head is going to be H equals to H dot next, right? Because
okay.
currently we stored H dot next equals to 3. Getting it?
Yeah,
Yeah. So as we are assigning here H equals to H dot next, by any chance, if your that node was unique, okay, then you need to assign it to your dummy node as well.
yeah.
So you
The,
will do this D dot next equals to H. Like you will attach your head node to the dummy if it is unique,
if it is unique, yeah,
right? Like I am talking about the case where it was like this. If it was unique, then you would have attached it,
correct. Yeah,
but you have already changed your head equals to H dot next. If this K was not there, that let me just highlight it. If
yeah,
this K was not there and H was there, then you have already like reassigned the value of H. You have lost one.
yeah,
So you will be assigning here 3, not 1,
yeah.
which will be wrong, right?
Right. Yeah. So one also is needed.
That's why as of now, we are storing our H dot next link in some temporary node. We are assigning our values to our like dummy node, and then we are reassigning it back. Like we are reassigning the value of K back to H.
Okay.
Clear?
Yeah.
If you have any questions now as well, you can clear it out. Are there any questions, Vishnu?
No, I'm just rethinking about it.
And by the way, your like the doubts which you had previously, that head node and all and the addresses, is it cleared now?
Yeah.
Okay, great. You can revisit this as well. It's fine. Okay, then. So we'll move into the next question for today. Yes. So the our next question is, you have been given a linked list. Let's name it as number 1 only. 3, 5, 8 minus 4 and then 10. Or you have been given another linked list as 1, 7, 2, 6, 3, and 9. So these are the two linked lists. You need to find the middle node of these linked lists. If you talk about this linked list, the middle node is 8. This is an even length linked list. So like it depends on what you want to return as. Either you can return the first middle node or the second middle node. So these and these are the two probable answers. So for like right now, if you're writing the code for these, just assume that you need to return the first middle node. Clear? Okay then. So can anyone write the code for this or think of it? How can it be done? Yes, guys, any brute force you can think of. We have done like 8.
Yeah, I was thinking that first find the size or call the size,
Mm-hmm.
and then divide it by 2,
And then
and then
iterate for that much time.
yeah, h dot next that many times.
Yeah, that's right. It will work out. That's correct. Any other way? Because yeah, what will be the complexity for this? Every time you're doing a question, I should not tell you that you should tell me the complexity. It should be a by default thing, okay? You're thinking any question, time complexity should be the first thing you are thinking of. Yes, so what will be the time complexity? Not order of n by 2 for sure, because you're gonna iterate for n times. And then you're gonna iterate for n by 2 times. So overall, it's gonna be n, order of n. Now, if you're thinking of any solution, it should be better than order of n. Clear? Okay. So like, do you guys want time for that, or should I directly explain the solution to this? 2 minutes? Yeah, you can take it. Okay, anything you think thought of? No worries, we'll directly move on to the solution. It is something new as well. So we use the concept of slow and fast pointers in the linked list. Okay. In terms of a slow pointer, it only moves one step at a time. That is, if you are at edge head, so you will move on the next step as head dot next. But if you are on the first node itself and it's your fast pointer, then it will move 2 steps. That is, f is equals to f dot next. Clear? Yeah. So this is the difference between the slow pointer and the fast pointer. So just try to iterate your linked list with this up to end, like up to your fast pointer reaches the end, and tell me in how many iterations is it finishing off. You all getting my point, right? Okay. Just do it manually and tell me. fast will move in n by 2 iterations. And by the time f reaches the end of the linked list, at that time, where is your slow pointer? Yeah, the slow pointer is in the middle, and that's the answer to this question. Clear? And the reasoning behind it is like, how come a pointer which is moving just double the first pointer is reaching, like exactly reaching the middle, is an obvious thing. That if some like one pointer is covering the entire length, the other slow pointer will be covering the half length only. Is it clear to all?
So if it is half, meaning, sorry, uh, if it is odd, then the fast will never be able to reach to the end.
Didn't get you?
So if we are using the fast pointer and the number of elements is odd, so it'll,
You can try it on the odd, no?
yeah. So one less position, it will be finding null.
Wish to try to iterate on the like the odd length and then tell me the answer. Did you iterate it?
Yeah, so two times in either both the nodes, both the linked
Slow.
list.
See, next step, slow will move here, fast will move here. On the very next step, slow will move here and fast will be here. Right?
Yeah,
And it has reached the end right now. So you have got your answer, like the slow, which is in the middle. If I talk about this, slow, fast, on the other step, slow will move here, fast will move here. On the next step, slow will come here, fast will be here. If you will try to move the next step, your fast is always moving f dot next, right?
yeah,
Yeah. So this time what will happen? This is next and this is null.
yeah,
So your like fast will reach null and your slow like this slow pointer will reach this. So this is also a middle,
yes,
but it is reaching the
middle, the
like it is
higher,
reaching the
higher end.
second middle, right?
Yes,
So you can just keep a condition in your while loop that if like you have to change your fast pointer only when it is not equals to null. So the point when it becomes equals to null, it won't allow it to enter. So it won't be changing the value for slow as well as the value for fast. Clear?
yeah.
Yeah.
And then
So
at that point, it will return the small to get the middle
correct.
element. Yeah,
Correct. And in any case you want this second middle, then you know that whatever slow pointer you have got, you just need to return slow dot next. Right? So I hope you won't be getting any problem in that. Okay,
yeah,
then should I write
yeah.
the code for this for you all, or will you be trying to write it? Yes, you should write it. And if you are not able to write it, I'll tell you. Great. I'll discuss another question then. It is a question which we have already discussed in the class, and you guys have like seen it 3 to 4 times in the class. It's just in the form of linked list. You have given two sorted linked list, that is -3 and 5, 8, then 20, then 25. Here the linked list is -1, 2, 4, 7, 11, 13, 16, and 18. These are your two linked lists which are sorted, and you need to merge them. You know the optimized way to do it, yes or no? Yes. So just you need to apply your that way in the linked list. Clear, everyone? Can I assume that you guys will be able to do it? Like at least you should give it a try. And tomorrow is Saturday and then Sunday. So you guys have enough, or you can say plenty of time to think of these questions and do it. Yes or no? I want majority to say yes if you guys want it as a homework. Just two people. 3, 4. Okay. It's more than enough. And if you all know, so you all can sort the linked list as well. Linked lists, very similar the way we sort the arrays. Okay, like all kind of sorting, namely bubble sort, selection sort, insertion sort, merge sort, etc., etc. All kind of sorting can be applied to the linked list as well. So this is the topic which you should explore on your own, because already the sorting has been covered. So you guys, when you will try these, your hold on the sorting will get better. Okay, you guys are stuck on any point in among these sortings, I'll help you, but I won't be explaining these topics like completely in the class. Okay, and try to do it, because you will understand like how you are linking the numbers and how you are delinking the numbers. So it will be a good experience for you all if you want them. Clear? Merge sort is something which I will explain. So if you are not able to do it, then also I'm going to explain it. Other than that, you have to look it on your own. All good? Okay. Should I explain another question, or is that enough for today? Can have. We'll have two then. So, yep. I'll name it as a fourth problem. You have Vishnu, I didn't get you. What you mean by explain?
Oh, no, you said that should we have another question? So for that one, I said
Okay.
yes.
Okay. So you have been given a linked list. Like this. And if you have been given the linked list like this, the result should look like 3, 4, 5, 9, 8, 2, and -1. Anyone getting any idea what is happening in the result?
Yeah, the opposite ends are coming in a sequence, and the middle element is at the last.
Yeah, like one by one, we are merging the numbers from the start and then from the last. So it basically looks like let's suppose the nodes are L1, L2, L3, L4, dot, 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 till Ln. Okay. So your resultant linked list look like L1, then Ln, then L2, then Ln minus 1, then L3, and then Ln minus 2. Similarly, this will continue. Clear? This is your result. Yep. How can it be done? Anyone has any idea how it can be done?
I mean, I can just think about that using fast linked list, traverse till the end,
Mhm.
and then
Fast linked list or fast pointer?
fast pointer, yeah.
Yeah. Then
And
continue.
then I was thinking using double linked list. So ln will give previous, and from L1 we'll have next, and from Ln we'll have previous until both becomes.
In these kind of
So
questions, generally in exam, you only have to finish the function definition. And in most of the cases, it's a singly linked list. So converting it to a doubly linked list and then again converting back to a singly linked list will be a whole lot of a job. So just think it in terms of singly linked list. Guys, just a question. Until when we are considering the nodes as an alternate one, like one from the first, then one from the last. Where is it ending? Like what is our last node in the result? Yeah, if you are able to hear me. No, I'm not asking that. I am asking in the result, like you have 3, 4, 5, 9, and your last node is -1, right? In your original linked list, where was -1? In the middle, right? So what you can do, you can find the middle element in the current linked list and then separate the two parts. Like you can have one part which have all the starting nodes and the other part which has all the ending nodes. Getting me? I'll explain you in the parts and you will get to know that we have solved each and every part separately. So first is finding the middle element. Have we done this? Yeah. After finding the mid, you need to detach a part. That you can do, right? Let's suppose you got the other linked list as like this was your mid. So from here is the head of the next linked list, right? You need to reverse the other linked list. Yes or no? Have we done the reverse part as well? Just the new thing in here is you need to take one node from here and the other node from here. So that you need to figure out, like attach the nodes at the end. The remaining two steps are already figured out. And I guess you all can figure out this step. Was it easy? Yes. Was it looking very tough? Was it looking very tough before I explained? Yes. So just think of the questions in these. Clear, everyone? I am again not going to give the code for this. So yeah, you have sufficient of homework this week. You can try
third
to.
one is not clear. Third part is not clear. Attach the nodes.
Okay, I'll
So
show you.
I'm just thinking it loud that 358 minus 1 is in the left node, left linked list.
First link
And
class, you can say.
yeah,
Yeah. And this 2, 9, and 4 is in the other linked list.
yeah.
Yeah. So like, let's suppose this is your H1, this is your H2. So if you need to start iterating, you will be writing it as that you want to point H1 dot next is equals to H2, right?
Yeah.
But if you will do that, you are losing your connection to this next node.
Yeah.
So for that, you need to write here that temp, some temp node where you will be storing this H1 dot next. Clear?
Yeah.
That this is done. After this is done, you need to make H2 dot next equals to null, right? Because there are so many nodes attached to it, but there should be nothing. Getting it?
Yeah.
So again, you need a temp variable, temp2, let's suppose, which will be storing H2 dot next.
Yeah.
And now you will be pointing H2 dot next equals to null. Clear? Clear or not?
No, so one thing about this doubt is that H2 should traverse from last element, which is the fourth. So we
No,
are,
I told you, no? Okay, sorry, my
okay,
bad.
okay, okay. Yeah, yeah. So we have to
My
do
bad.
reverse in
Yeah,
between.
we
Yeah.
need to reverse it. I thought I have already taken a reverse linked list. So yeah, you're right.
492.
So here it should be 4 and here should be 2.
Now it's making that.
Clear? And after that, you can simply make your new H1 as temp. That is nothing but where? Yeah, 5. But one thing we forgot, that is you attached 3 to 4, right? But you're forgetting, if you're making this as H1 now, this 5 should be having the link with your H2, right?
Yeah. 9.
Yeah. So instead of this null, you can write here, it should be temp. Clear? Then you can make your H1 as temp and you can make your H2 as temp 2. They will be in the while loop, obviously, and that conditions and all you all can, I hope, figure out. I have done most of the question for you right now. Clear, guys? Okay. Is linked list interesting now? Oh my God. No, yes, no, no. Okay. Does anyone is finding it kind of tough or somewhat, you can say, stuck in?
Ma'am,
It is,
actually, my
it,
math is not well, so I'm not getting time to practice.
you should practice because this topic is something which when you learn, you find it way too tough. But once you start practicing, you love this topic. This is the beauty of linked list. Recursion is obviously a difficult topic. I never said it's easy, but yeah, understanding the analysis of recursion is way too great. If you are able to understand it, you love like learning recursion. Okay, then. And if you love recursion, then you will be very good at DP as well. So you have two benefits of that.
Sorry, say that again. If you love recursion, then what will happen?
Then you will be very good at DP, dynamic programming.
Okay.
Okay, then, guys, have a very nice weekend. Do practice and we'll meet on Monday. Okay? Yeah. Okay, then. Thank you for attending the session. Bye. Good night.